All right, here is Unit 9, Day 8. This is the last day and the last unit and the last everything for the year. So this is it. This is the last new material we're going to be learning. It is solving rational equations Day 2, so it's basically an extension of what we did on Day 7. So if you remember, well, I'll just go to the learning target here. Learning target is I can solve rational equations and recognize extraneous solutions. It's pretty much the same thing as last time. And solve and check for extraneous solutions. So not a whole lot different. It's just different kinds of problems. So same idea. We're going to look at these problems. We're going to look at what would be the least common denominator of the bottoms here, and then multiply every term by that. So on this guy, on this first one, the least common denominator, if we look at all the factors, well, these are factored completely, the least common denominator would be x plus 1 times x minus 2. Okay, and so we can think we're going to multiply all of these by that. Now this first one, if I multiplied by x plus 1 times x minus 2, the x plus 1 would cancel out this x plus 1, and all that would be left would be x minus 2. I'm just going to multiply it by, I think of what's missing. So like this one, it's missing the x minus 2. It has the x plus 1, but it's missing the x minus 2. That's what I multiply by. This guy here, it's missing the x minus 2. I'm sorry, it has the x minus 2. It's missing the x plus 1. So that's what I'm going to multiply by. Again, that's because if I multiply by the whole thing, the x minus 2's would cancel out. Now this has no denominator, so it needs to be multiplied by both of those. Okay, so I'm going to multiply this by x plus 1 times x minus 2. Okay, and when we're done multiplying this, there is no denominators left because everything canceled out. So this would be x squared minus 2x plus x squared plus x. And then on the right side here, I would have, let's see, well, if I multiply these together, I get x squared, and then minus 2x plus 1x would be minus x, and then this would be minus 2. I'm actually going to double all of those then, so it would be 2x squared minus 2x minus 4. Okay, so now when I go to solve this guy, I notice I have x squared on both sides. I'd love to have a positive x squared, so I'm going to subtract x squared from both sides. It means I'm going to be taking everything to the right side now, since that taking everything to the right would result in a positive x squared. Plus 2x plus 2x. Oh, I messed up here. I'm sorry. Scratch that. Let's combine this. That'd be 2x squared minus 2x. I'm sorry, minus 1x. I got ahead of myself. I didn't simplify the left side. So scratch that part. So here I just got x squared plus x squared is 2x squared, and then that'd be a minus x. And now let's start bringing stuff. So if I subtract 2x squared from both sides, and this is a 1, so that would be, I'll just say negative x equals negative 2x minus 4. Bring this to plus 2x would be x equals negative 4. Okay, so x equals negative 4. Now, if I go to plug those guys in, it looks like nothing, if I plugged in negative 4 here and here, that doesn't mess with any of the, doesn't make 0 in the denominator. And if I plug that in, it does work out. Number 2, and look for what's the least common denominator. Okay, so this one would be x times x plus 2. If I multiply here, the x's would cancel out, and I would just be left with x plus 2. Here, the x plus 2's would cancel out, and I'd be left with just x, and here I'd have x times x plus 2. So I'd have all of that. So on this side, I got 15x plus 30 plus 9x squared minus 7x. And then on the right side, this guy here would be x squared plus 2x. When I multiply those together and distribute the 9 out, so 9x squared plus 18x. Okay, so do some combining here. Well, first off, I see just the 9x squares. I'm just going to wipe those out. If I subtract 9x squared from both sides, they're gone. So 15x minus 7x would be 8x plus 30 equals 18x. So if I subtract 8x, so x equals 3. And if you plug that back in, plug it back in for all of these, nothing goes to 0. And in fact, 15 divided by 3, if I plug 3 in there, would be, so let's say 15 divided by 3, 9 times 3 minus 7 over 3 plus 2. So this would be 5. And then this would be 20 over 5, which is 4. 5 plus 4 does equal 9. So that's not an extraneous solution. That one does work. Okay. Number 3, if you're looking at your least common multiple, some of you might recognize pretty quick that x squared minus 9 factors into x plus 3 times x minus 3. So that means my least common denominator is x plus 3 times x minus 3. So if I go to multiply all of these by that, well, the x plus 3's would cancel. I'd be left with x minus 3 on top. The 5 already has x minus 3, so I'd be left with x plus 3 on top. This one has both of those, so I don't multiply by anything. If I multiplied by this, they would wipe all that out, and it would just be 6. So I've got 2x minus 6 minus, that's going to be negative 5 times x, but it's also negative 5 times 3, so minus 15. And on the right side is just 6 left over, because when I multiplied by this, the entire bottom canceled, so there's just 6. Okay, so this would be a negative 3x minus 21 equals 6. Add 21. Negative 3x equals 27. If I divide by negative 3, x would be negative 9. Plug them back in up top. It does check out. It's a bunch of fractions. Again, I'm going to save time in the video, but it's kind of some weird fractions. But when you type in the calculator, you get the exact same decimals on both sides, so it is equal. Number 4, let's see, least common denominator. If you look, this here, if I factor that, it'd be minus 3 plus 1, because product is negative 3, sum's negative 2. So that is my least common denominator, is x minus 3, x plus 1. So you think, okay, what's missing? So this one has the x minus 3, it's missing x plus 1. This one has the x plus 1, it's missing the x minus 3. This one's not missing either one, so I don't need to multiply by anything. So I've got 4x plus 4 equals 2x minus 6, again distributing that out there, plus 16. So 4x plus 4, doing some solving here, 2x plus 10. If I subtract 4 and then subtract 2x from both sides, I get 2x equals 6. So x would be 3. Now I can see pretty quick when I plug this in, this first denominator right here, when I plug 3 in, that first denominator becomes 0, so that can't be a solution. So I got to throw that out. Since it was the only possible solution, it didn't work, then there's no solution. There's no real solution to that one. Next guy here, and 2 more. We got least common denominator. If we factor this, you'll see that that is negative 3 and negative 4. Product is 12, sum's negative 7. So if I look at my factors here, that means x minus 3 and x minus 4. That's my least common denominator. First one, nothing's missing, so that's just going to be a 5. The next one, I'm missing an x minus 3, so I'm going to multiply by x minus 4, so it'll be 4x minus 8. On the other side, I have the x minus 4, I'm missing an x minus 3, so that would be a 5x minus 15 when I multiply that out. So combining the sides here, I've got, let's see here, did I mess up? Yeah, I did mess up 2x, that should be a 2x there. That is minus 8, so I got 2x minus 3 on the left side, 5x minus 15, subtract 2x from both sides, 15. This would be 12. So when I divide by 3, I get x equals 4. And again, It's sort of like this last one up here. When I plug 4 into those denominators, right there's 1, that equals 0. And actually this one also, if I plug it in over here, these two denominators would equal 0. Can't calculate those, so that gets thrown out, so it's no solution again. Okay, so last one, you guessed it, this is x plus 3 and x minus 5. So my least common denominator, x plus 3, x minus 5, going off page there. But first one's not missing anything, so if I multiplied by this, the bottom would cancel out and I'd be left with 56. This one has an x plus 3, it's missing an x minus 5. So think of this as a negative 6, and I'm going to distribute out. So it'd be negative 6x, and then it'd be a plus 30. And then the last guy has the x minus 5, is missing an x plus 3. So distribute that out, 7x plus 21. Okay, so let's see, negative 6x plus 86. Getting like terms together. So I've got, let's see, 65 and 13x. When I divide it by 13, I get x equals 5. Okay, now not possible. Well, if I plug it in, that one and that one would become 0, so I have to throw that out. So again, it's no solution. So we have a lot of no solutions on the practice problem. It doesn't happen that often, quite that often in your homework, but just want to give you plenty of examples of when it is no solution so you're not caught off guard on the homework.